Good evening, children.
Good evening, ma'am.
Good
Good
evening.
evening.
Good evening, children. I've shared my screen. Visible to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah, very good. Okay, so in this question, find the central angle theta. So for those who did not attend the last one or two classes, we've started areas related to circles. And I think this is the second or third session. This is session 3. Okay, session 3 this is. Areas related to circles, session 3. Okay. So in this question, we have to find the central angle theta. Yeah. In the first figure, what's the value of theta? What's the value of theta in the first figure? Okay, it's 60 degrees because AOB is an equilateral triangle. AOB is an equilateral triangle. You can see every side of the triangle measures 14 centimeters. So therefore, theta is equal to 60 degrees. In the second one, we know that OA is equal to OB, radii of the same circle. OA is equal to OB. So if OA is 5, OB is also 5. Now we'll first use the converse of Pythagoras theorem. Now this one is an isosceles triangle. It is not equilateral. Okay, so how do we find theta? We'll try to check the converse of Pythagoras theorem. For that, what is root 50? Root 50 is 5 root 2. It's nothing but 5 root 2. So the longest side of this triangle is 5 root 2. Square root of 50 is nothing but 5 root 2. So the longest side of the triangle is 5 root 2. So we'll find the sum of the squares of the other two sides. 5 squared plus 5 squared. 25 plus 25, 50. And then we'll find the square of the longest side separately. 5 root 2 into 5 root 2, which is 25 into 2, 50. So clearly, OA squared plus OB squared is equal to AB squared. OA squared plus OB squared is equal to AB squared. Therefore, by converse of Pythagoras theorem, theta is equal to 90 degrees. Why theta is 90? Because the angle opposite the longest side, AB is the longest side. AB is the longest side. The angle opposite of the longest side is a right angle. So theta is 90 degrees. See here, the first one, this is the first figure. OAB is an equilateral triangle, therefore theta is equal to 60 degrees. In the second figure, we find OA square and OB square, 5 square plus 5 square, 50. We know that AB is the longest side, so we square that separately. Square the longest side separately, and then the sum of the other two sides, the sum of the squares of the other two sides separately. So you see that it's 50 in both the cases. So OA square plus OB square is equal to AB square, which means the angle opposite to the longest side is AB. The angle opposite to that is a right angle. Therefore, angle AOB is equal to 90 degrees, which means theta is 90 degrees. In the third figure, you can check OA square plus OB square. You can check OA square plus OB square with AB square. They'll not be the same. So that means theta is not 90. It will not be equal. That means theta is not 90. In which case you can find theta using trigonometry. So draw OM perpendicular to AB. That's the construction. Draw OM perpendicular to AB. Okay. Draw OM perpendicular to AB. So now we know that these two triangles will be congruent by the RHS congruence criterion. Right angle, hypotenuse OA is equal to hypotenuse OB, and OM is the common side. In these two triangles, 90 degrees, 90 degrees, that is R. Hypotenuse OA is equal to hypotenuse OB, H, and some other side. OM is the common side. So by RHS congruence criterion, the two triangles are congruent. So CPCT, we have AM is equal to MB. So the whole thing is 42 root 3. So it's 21 root 3 here, 21 root 3 here. All right. And also this angle will be equal to this angle. This angle will be equal to this angle. So that's what you see here. AM is equal to MB CPCT, and angle AOM is equal to BOM CPCT. Now take up this right triangle. Take up this right triangle OMB. We need to find what? We need to find theta. Okay, we need to find this angle. So connect this angle with the opposite side and the hypotenuse. See, for this angle, this is the opposite side. For this angle, this is the opposite side. This is the hypotenuse. So you need to connect this angle with the opposite side and the hypotenuse. The known sides. You need to connect the angle with the known sides. Okay. So opposite hypotenuse, so sine theta. So sine of angle BOM, sine of angle BOM is equal to opposite BM by hypotenuse OB. We need to find this whole angle. For that, we'll find this angle using trigonometry. So sine of angle BOM is equal to opposite 21 root 3 by hypotenuse 42. So when you work that, you get root 3 by 2. And when is it root 3 by 2? Sine 60 is root 3 by 2. So sine of angle BOM is equal to sine 60. So on comparing both the sides, angle BOM is 60 degrees. So BOM, this one is 60. So this whole angle is 120 degrees. This whole angle is 120 degrees. You can also find for the second figure, okay, here also we can use trigonometry. For the second one, we actually use the converse of Pythagoras theorem. You can also use trigonometry here. Trigonometry you can always use. Okay. So here you drop OM perpendicular to AB. Okay. This is 5. This is also 5. Now, I'll just draw the triangle alone. This is a triangle. All right. O, A, B, and we drop OM perpendicular to AB. All right. This is 5. This is 5. So triangle OMA will be congruent to triangle OMB by the RHS rule. Right angle, hypotenuse equal, and common side. So CPCT, you will have AM is equal to BM, CPCT. And also this angle, this angle will be equal to this angle. So angle AOM is equal to angle BOM, CPCT. All right. So then what is AM? The whole thing AB is root 50, right? AB is equal to root 50. That is root of 25 into 2, which is 5 root 2. So how much is BM then? BM is equal to 5 root 2 divided by 2. So here BM is equal to 5 root 2 divided by 2. Because the whole thing is 5 root 2. Root 50 is 5 root 2. So AM will be, AM and BM are half of AB. So 5 root 2 by 2. Now in this triangle OMB, this is 5. This is 5 root 2 by 2. And this angle is, this is not theta. The whole angle is theta. So now you need to connect this angle with the opposite side and hypotenuse. So sine of angle BOM is equal to opposite BM by hypotenuse OB. So that is okay, that is equal to 5 root 2 by 2 divided by OB divided by 5, which is 5 root 2 by 2 into 1 by 5. Division becomes multiplication and the reciprocal of 5 is 1 by 5. 5 cancels. Okay, root 2 by 2. When you cancel, you'll get 1 by root 2. So sine of angle BOM is equal to 1 by root 2. In the sine table, when do we have 1 by root 2? Sine 45. Sine 45 degrees is 1 by root 2. So on comparing both the sides, angle BOM is equal to 45 degrees. Okay, if angle BOM is 45, what is theta? The whole angle AOB. Okay, I'll just continue here. Okay, therefore, angle AOB is equal to 2 into 45, 90 degrees. Yeah, please write down, draw this figure. One minute, just a minute. Yeah, write down, children. Find the central angle theta. Find the central angle theta. Done, children?
Yes, ma'am.
Yeah, this is the next one. Same heading, find the central angle theta. Find the central angle theta. You know, if OA is 5, OB is also 5. Completed, children?
Yes, ma'am.
Okay. Others? Tanishka says yes. What about others?
Yes, ma'am.
Okay, good. Bhavishya. Yeah, write down. Please complete this. I'll just come back. Yeah, find the area of the minor sector. This is simple. Yeah, please work this. Minor sector is this full area. Done, children?
Yes, ma'am.
Yeah. This is the next one. Find the radius of the sector whose area is 4.4 centimeter square and central angle is 56 degrees. So this is a sector. The central angle is given 56 degrees. We need to find the radius of the sector. The area is given to you. Area of the sector is 4.4 centimeter square. So given the area and the central angle, you'll have to find the radius of the sector. Yeah, please work. These are very straightforward questions. I'm not explaining. You can help yourself. Please work out. Four 4.4, I've written it as 44 by 10. 4.4, I've taken as 44 by 10. Done, children?
Yes, ma'am. Done, ma'am. Yes, ma'am.
Yeah. All right. Yeah, this is the next question. Completed, children? Okay. So first sector angle, we know it's an equilateral triangle, so the sector angle is 60 degrees. Next, the area of the minor sector. Minor sector is this one. Area of the minor sector is theta by 316 to pi r square. So 60 by 316 to pi r square. Area of minor sector. Then next is to find the area of the triangle. The triangle is an equilateral triangle, so its area is given by root 3 by 4 into side square, where side is 15 centimeters. Next is to find the area of the minor segment. Which is the minor segment? This one is the minor segment. This is the minor segment. So we see that the sector is made up of a triangle. This minor sector, it's made up of this triangle and the minor segment. So from the area of the sector, if you take away the area of the triangle, you can find the area of the minor segment. This is the minor sector. What you see here is a minor sector. It's made up of two figures, equilateral triangle and minor segment. So from the area of the sector, if you take away the area of the triangle, you can find the area of the minor segment. So minor sector minus triangle is minor segment area. Next is to find the area of the major sector. Major sector. Again, theta by 316 to pi r square. What's theta? 300. 300 by 316 to pi r squared. Then finally, the area of the major segment. Major segment. So see here, this is the major segment. See, this is the minor segment. This one is the minor segment. This one is the minor segment. So the rest of the circle is the major segment. The rest of the circle called minor segment. Minor segment. The rest of it is the major segment. The rest of the circle is the major segment. So see here, this is the minor segment. This is the minor segment. Now, if you take away the minor segment, the rest of the circle is the major segment. So the major segment, as we see, is made up of the major sector and this equilateral triangle. The major segment, see, this is the minor segment. The rest of it is the major segment. And what is the major segment made up of? It's made up of the major sector and the triangle. Major sector and the triangle. So area of the major segment is equal to area of the major sector plus the area of the triangle. Sector area plus triangle area. Done, children?
Yes, ma'am.
Okay. Yeah, quickly finish all this. These are 1-mark questions. Yeah. Next one. In the given figure, OPQR is a rhombus. OPQR is a rhombus. Three of whose vertices lie on a circle with center O. Yeah. The vertices P, Q, and R of the rhombus lie on the circle. The fourth vertex O is the center of the circle. So 3 out of 4 vertices of this rhombus lie on the circle. If the area of the rhombus is 32 root 3 centimeter square, find the diameter of the circle. The area of the rhombus is given. Find the diameter of the circle. Present the answer. Please go through. Then I'll explain. Children, please go through the answer, understand and work it out. All right. So Yeah. So it's given that OPQR is a rhombus. And we know that in a rhombus, all the sides are equal. In a rhombus, all sides are equal. OP is equal to PQ is equal to QR is equal to OR. In a rhombus, all sides are equal. See? Okay. Okay. Now, OP is equal to OQ. Why OP is equal to OQ? Okay. Now, in this figure, which are the radii? OP, OQ, and OR. They are the radii of the circle. OP, OQ, and OR are the radii of the circle. Now, OP, OQ, and OR. Now consider this. In the rhombus, OP is equal to PQ. All the sides are equal, no? All the sides are equal. So in this rhombus, OP is equal to PQ. But OP is equal to OQ. Why is OP equal to PQ? Because in a rhombus, all sides are equal. But why is OP equal to OQ? Radii of the same circle. So when you compare these two results, OP is equal to PQ is equal to OQ. All the three are equal. You can, because OP is equal to PQ and OP is equal to OQ. That means all the three are equal. OP, PQ, and OQ are equal. So if OP is equal to PQ is equal to OQ, that means this triangle is an equilateral triangle because all the three sides are equal. Now do the same thing to the other triangle. Which are the two sides of this triangle? OR and QR. OR is equal to QR. OR is equal to QR. Why is OR equal to QR? Because in a rhombus, all the sides are equal. But OR is equal to OQ, radii of the same circle. So when you compare these two results, we have OR is equal to QR is equal to OQ. OR is equal to QR is equal to OQ, which again means this triangle is an equilateral triangle. All the three sides are equal. And the two triangles, the two equilateral triangles will be identical because see, they have this common side, no? So they are two identical equilateral triangles. See, this is the common side. So like if this is 5 centimeter, for example, then this is 5, this is 5. And also this will be 5, this will be 5. So these two are identical equilateral triangles. Let's just see it again. See here. We know that radius OP, radius OQ, radius OR. Okay. Now in this figure, take up in the triangle above here, in the triangle above here, take up this side and this side, the triangle above. So you start like OP is equal to PQ. OP is equal to PQ because in a rhombus, all the sides are equal. But OP is a radius, right? The radius OP is equal to OQ, radii of the same circle. OP is equal to OQ, radii of the same circle. So when you compare these two results, OP is equal to PQ is equal to OQ. So that means this triangle is an equilateral triangle. Same thing below. This side is equal to this side. Okay, OR is equal to QR because in a rhombus all the sides are equal. But OR is equal to OQ. OR is equal to OQ. because OR radius, OQ radius. So OR is equal to QR, but OR is equal to OQ. So when you compare these two results, we have OR is equal to QR is equal to OQ. OR is equal to QR is equal to OQ. The three sides are equal. And you see that this side is common to both the triangles. So both the triangles are identical equilateral triangles. So then what is the area of the rhombus? The area of the rhombus is 2 into area of rhombus is equal to 2 into area of equilateral triangle. Because this rhombus is made up of two equilateral triangles. So area of one equilateral triangle into 2 is the area of the rhombus. And that is given to be 32 root 3. So 2 into root 3 by 4 into side square. Okay, we have to find the diameter. So we don't know the side. That's a radius. The side is nothing but the radius. 2 into root 3 by 4 into side square. Okay, which is nothing but the radius. Radius square is equal to 32 root 3. So when you work this, you can find the radius of the circle, double that to get the diameter. If you have not finished, please complete. Done, children?
Yes, ma'am.
Okay. Find the area of a quadrant whose perimeter is 25 centimeters. Try this.
Ma'am,
Yes, Tanishka?
this question we have done already.
Oh, really? Okay. I think it's a repeat then. I have the same question in this presentation. Okay, okay. Okay, thank you. Okay, find the area of a quadrant whose perimeter is 25 centimeters. So this is a quadrant. It's a quarter of a circle. 1/4 of a circle. This is a quadrant. Its perimeter is given. Perimeter is 25. That means OA plus OB plus the length of this arc AB. Perimeter, right? So OA plus OB plus the length of arc AB is equal to 25. OA is R, OB is R, and the length of arc AB. How do we find the length of arc? Theta by 360 into 2 pi r. Length of arc. Theta by 360 into 2 pi r. So substitute that is equal to 25. R plus R is 2r. And when you cancel here, you get 1 by 2 into, you can see here, after cancelling, we have pi r. So 1 by 2 into pi is 22 by 7 into r is equal to 25. So on working this, we find R is 7. And the area of the quadrant is 1 by 4 into pi r square. Or area of quadrant is 90 by 360. Theta by 3, because a quadrant is a sector. A quadrant is a sector. See a radius arc. A quadrant is a sector. So you can also use a sector formula, theta by 360 into pi r square. Or because it is 1/4 of a circle, 1 by 4 into pi r square. Yeah. Okay. Next one. Find the area of the largest triangle that can be inscribed in a semicircle of radius r. Find the area of the largest triangle that can be inscribed in a semicircle of radius r. So the largest triangle meaning it should have, what's the formula to find the area of a triangle? Half base into height. So it should have maximum base and altitude. Find the area of the largest triangle, biggest triangle that can be inscribed in a semicircle. So the triangle should have maximum base and height. So see here, this is the largest triangle that can be inscribed in a semicircle. This is the semicircle. This is a semicircle. And this is the largest triangle in the semicircle. What will be the base? The base is 2r diameter and the altitude is r. The area of triangle ABC is equal to half into base AB into altitude OC. Why are we using this formula half base into height? Because we know that angle in a semicircle is a right angle. This is 90 degrees. Okay, so you can do it both the ways. 1 minute, I'll just explain this first. So area of this triangle is equal to half base into height, half into base AB, which is 2r, into altitude, which is r. So I'm cancelling, you get r square per unit. Please write down. These are all questions for 1 mark, children. Done, children?
Yes, ma'am.
Okay. Others? Okay. I think this also we took up in the last class, right? Have we completed this, children?
Yes, ma'am.
Okay. Yeah. So area of 1 hectare. 1 hectare. What is hectare? Hectare is a unit for area. Hectare is unit for area. 1 hectare is equal to 10,000 meters square. 10,000 meters square. Yeah, the rest you can understand. Please do this. Okay. So area is given 0.5 hectares. Multiply by 10,000 to convert area to meter square, because 1 hectare is equal to 10,000 meters square. So multiply 0.5 by 10,000 to convert area to meter square. Okay, and that's nothing but that's equal to 5,000. 5,000 meters square when you multiply. Okay. So area of square is equal to 5,000 meters square. When you multiply this, you get 5,000. So area of square is 5,000 meters square. What's the formula to find the area? A square. Area of square is equal to A square. A square is 5,000. So A is square root of 5,000. So A is 50 root 2. And now how will you find the diagonal? The formula is root 2A. Formula to find the diagonal is root 2A. So root 2 into 50 root 2, which is 100. You can also do it like this. Area of square in terms of diagonal is half diagonal square. Area of square is equal to half into d square, half into diagonal square. We have to find the length of the diagonal, right? So you can directly get it using this formula. area of square is equal to half into d square, half into diagonal square. Area is 5,000, but the formula to find area is half d square. Why we write this? Because we have to find the diagonal, no? So let's use this directly. Half d square is equal to 5,000. So d square is equal to 5,000 into 2. D square is 10,000. D is square root of 10,000, which is 100. This formula is diagonal is equal to root 2 into side. Root 2 into side. So we find the side of the square and then root 2 into side to get diagonal. Here we use this formula directly, which involves the diagonal, half d square. Area of square is equal to half d square. And find d. Completed? Okay. Yeah, this is the next question. Find area of the shaded region and also perimeter of the shaded region. Area of the shaded region will be, you can see here, this one, all these are semicircles. The area of this semicircle minus the area of this semicircle will be the area of the shaded region. The area of the shaded region, this one, the area of the shaded region is equal to area of this semicircle minus the area of this semicircle. How do you find the area of the semicircle? What's the radius? The diameter is, this is 7. From here to here is 7. And from here to here is 3.5. This one is 7, children. This one is 7. And this one is 3.5. This one is 7. This one is 7. From here to here is 7. This one is also 7. This one is 3.5. Oh, it's marked 7 from here to here. Huh? From here to here is 7. Let me just check that. AC is 7. No. That's what I'm right. AC is not 7. This is 7, children. This from here to here is 7. Okay. Let me tell you. See here. AD is 7 centimeters. AD. Then DC is 3.5. CF is 7. And FH is 7. Now the area of the shaded region is equal to area of this semicircle. Semicircle area is half pi r square. And the diameter is, from here to here is a diameter. This is a semicircle, right? So this one is the diameter. And what's the diameter? It's 10.5. 7 plus 3.5, 10.5 is the diameter. So what will be the radius? 10.5 by 2. So area of that semicircle, formula is half pi r square for area of a semicircle. And the radius is 10.5 by 2 minus area of this semicircle. Again, area of semicircle half pi r square, but the radius will be, the diameter is 7. So the radius will be 7 by 2. Next, we'll have to find the area of this shaded region, this region. which is the area of this semicircle minus the area of this semicircle. Area of this semicircle minus the area of this semicircle will give you the area of the shaded region. Semicircle formula to find area, half pi r square. And see the semicircle, this is the semicircle. So this is the diameter. This one is the diameter. This one is the diameter. What's the diameter? 7 plus 7, 14 plus 3.5. 17.5 is the diameter. By 2 is the radius. Minus the area of this semicircle. Diameter is 7. So radius 7 by 2. So we found the area of this region. Now let's find the area of this region. So this one is clearly a semicircle with radius, with diameter 7. So radius 7 by 2, half pi r square. And radius is 7 by 2. So find the areas of these three portions and add to find the total area of the shaded region. To find the perimeter of the shaded region, you need to go along the boundary of the shaded region. So say you start from here. What is the length of this arc plus 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 the length of this arc is the perimeter of the shaded region. But to find the perimeter, just walk along the boundary of the shaded region. To find the perimeter of the shaded region, you just have to walk, you just have to go along the boundary of the shaded region. Okay. So see here, the length of this arc, and what is this? What do you mean by length of this arc? It's a part of the circumference of the circle, right? So this is semicircle. So circumference is 2 pi r. So semicircle will be pi r, 2 pi r by 2, pi r. The length of the full circle is 2 pi r. The length of the full circle is 2 pi r. So the length of half of the circle or semicircle is pi r. The length of the full circle is 2 pi r. So the length of the semicircle will be pi r because 2 pi r by 2, so pi r. Okay. So length of this arc, pi r. The length of this arc is pi r. What is r? It's 7 by 2 because from here to here is 7. 7 by 2 is r. Plus the length of this arc. This is also a semicircle. What's the length of this arc? Pi r. You can say pi r1 plus pi r2, pi r3 to differentiate. Okay, so pi r. I'm saying pi r because 2 pi r is for the circle. So 2 pi r by 2. Pi r is the length of a semicircle. But what is r? Pi into r. What is r? 7 plus 7, 14 plus 3.5. 17.5 divided by 2 is r. Then plus the length of this arc. Plus the length of this arc. Same formula, children. Pi r is a formula and find the radius. Plus the length of this arc, pi r. Plus the length of this arc, pi r. Will give you the perimeter of the shaded region. Yeah, please work. Yeah, please work, children. I'll just explain this so that it's comfortable for you to work. So what I've done is I've marked this region 1. I've marked this region 1, this one 2, and this one 3 children. Okay. So area of region 1. How do you find area of region 1? Is the area of this semicircle. That is formula half pi r square. So half into pi into r square. What's the radius here? AC by 2. Diameter is AC. So AC by 2 is the radius. So this is radius. Radius square. Half pi. This is r square. What is r? Diameter is AC. So AC by 2 is the radius square minus the area of this semicircle, which is also half pi r square. So half into pi into r. What is r? AD by 2. Diameter by 2. AD by 2, the whole square. This is r. Then you have to substitute the values and you can understand. I've taken out pi by 2 common because half pi, that is pi by 2. That's common. Half pi means pi by 2 is common. Okay, that's about the, so like that I've worked for area of the region 1, 2, and 3. And then to find the area of the shaded region, totally area of region 1 plus 2 plus 3 is the area of the total shaded region. Then to find the perimeter, see here, length of arc AED, length of arc AED. AED is this arc, AED is this arc. Length of arc AED plus length of arc DIH or HID, okay? Length of arc HID or DIH plus the length of arc HGF. Okay, length of arc FGH plus the length of arc CJF plus the length of arc CBA or ABC. And all these arcs are semicircles. Okay, so length of a circle 2 pi r, semicircle 2 pi r by 2 pi r. So everywhere you will see pi r, pi into r plus pi into r plus pi into r. And for r, I've substituted diameter by 2 everywhere. Yeah, please work. Okay, I hope all of you completed.
Yes, ma'am.
Working? Need time?
Done, ma'am.
Okay. So tell me, how do you find the area of a semicircle? Area. What's the formula to find the area of a circle?
Pi r
Pi r square. So area of a semicircle?
pi r square by 2.
Pi r square by 2. And length of a circle? Perimeter.
2 pi r.
2 pi r. And the length of a semicircle will be 2 pi r by 2, which is pi r. So we should be careful in using the formula, that's all. And substituting the values. I repeat, see here, this is a semicircle with diameter AC, with diameter AC. AC is the diameter, 10.5. Radius will be 10.5 by 2. So radius we'll have to substitute correctly. And the formula, pi r square by 2 or half into pi r square is the area of this semicircle minus the area of this semicircle. Again, formula half into pi r square or pi r square by 2. And this is the diameter, 7. 7 by 2 is the radius. So area of this semicircle minus the area of this semicircle will give you the area of this shaded region. Area of this semicircle minus the area of this semicircle. Okay, will give you the area of this shaded region. So you should be careful in finding the diameter and then the radius. So diameter is, if this is the semicircle, the diameter is from here to here. This is the diameter. Half of that is the radius. Semicircle, 7 is the diameter. So by mistake, if you take the radius as 7, then even if your formula, everything is right, your value substitution is wrong, so you will lose marks. So this is the diameter. So radius will be 7 by 2. And here, region 3, area of semicircle, half into pi r square. R is 7 by 2. So like this, you find area. Perimeter is the length of the boundary. Remember that. Perimeter is the length of the boundary. You should just go along the boundary of the shaded region. So the length of this semicircle plus 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 the length of this semicircle. So totally 1, 2, 3, 4, 5 semicircles are here. So you should add the lengths of these 5 semicircles to find the area of the, to find the perimeter of the shaded region. And to find the length of the semicircle, length or the perimeter of the semicircle, the formula is pi r. Pi r, 2 pi r by 2, pi r. So this is pi r, this is pi r, pi r, pi r, and pi r. All right. Completed, all of you?
Yes, ma'am.
Oh, all right. This is the next one. So APB and CQD are semicircles of diameter 7 centimeters each. 7 centimeters each. While ARC and BSD, ARC and BSD are semicircles of diameter 14 centimeters each. Find the perimeter of the shaded region. area of the shaded region. Yeah, please work. You're not blindly copying, children. I'm presenting so that you can work and check the answer which you see on your screen. Please do not copy blindly from the screen. Write down the question. Do it by yourself. And after every step, check your step with the answer you see on your screen. Done, children? Completed, all of you?
Yes, ma'am.
Okay. Is the answer complete on this slide? I have another slide here. What is this? Perimeter of the shaded region. Okay, then area of 1, 2, and together. Yeah, what is this one? Was the answer here meaningful, children? It was related to the question, right? This answer? Length of arc APB. Pi r. So pi into 7/2. BSD pi into 7. Yeah, okay. Area of 1 half pi r square minus it, and then 2. Yeah. Okay, so there's something else. Okay, see the next question. The inside perimeter of a running track is 340 meters. The inside perimeter of a running track is 340 meters. The length of each straight portion is 60 meters. And the curved portions are semicircles. Okay, so the ends are semicircles. Okay, so these are the straight portions from here to here. Straight portions from here to here. Okay, so these are the straight portions. So this is the running track. The inside perimeter of the running track is 340 meters. That means the length of this line segment plus the length of this line segment plus the length of this semicircle plus the length of this semicircle is equal to 340. See, now there are two things in this running track. This is called the inner edge. This one is called the inner edge. Inner edge. This is called the outer edge. Outer edge. This full thing is called the inner edge. This full thing. That is this one, this one, this one, and this one together. All together is the inner edge. The outer edge is this, 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 and this together is the outer edge. Outer edge. So the inner edge is made up of two straight portions and two semicircles. The outer edge is also made up of two straight lines and two semicircles. The inner edge of the track is made up of two straight lines and two semicircles. The outer edge of the track is made up of 2 straight lines and 2 semicircles. Now all these 4 straight lines will have the same length. Okay, all these 4 straight lines will have the same length. The inner semicircles are smaller than the outer semicircles. The 4 line segments will have the same length. The inner semicircles are smaller than the outer semicircles. So let's draw the track again. See here. These are the 4 straight portions. Outer semicircle, inner semicircle, outer semicircle, inner semicircle. So this is the running track. These are the 4 straight line segments. These are the 4 straight line segments. All of them have the same length. Semicircle, semicircle. Smaller than these 2 semicircles. Okay, so now which is the inner edge? The length of this line segment. Children, just excuse me, I'm just coming. There's somebody at the door. Yeah, thank you, children. So I was telling you about the inner edge and outer edge. So the inner edge is made up of 2 line segments. These 2 straight line segments. This one and this one. And the 2 semicircles. That's the inner edge. The outer edge again, this line segment, and these 2 outer semicircles. Okay. So what is given? The inside perimeter of the running track is 340 meters. So if you call this L, okay, supposing we call this L, and this one will be pi r because semicircle. 2 pi r is circle, pi r semicircle, pi r. The outer ones will be pi capital R, pi capital R. Okay, this is again L. This is also L. Now the inside perimeter will be L plus pi r plus L plus pi r is equal to 340. The length of each straight portion is 60 meters. Okay, that's given 60. So that means 60 plus pi r plus 60 plus pi r is equal to 340. So when you work this, you can get the value of r. You can get the value of r. And the curved portions are semicircles. If the track is 7 meters wide, if the track is 7 meters wide, this is the track. This is where the athletes, like run or whatever sport is it's conducted here. Okay, so this is that place in the middle where people can sit and watch the games happening. So this is the portion in the middle. Okay, so this is the track. This is the width of the track. This is the width of the track, and that is 7 meters. So once you find the inner radius, supposing this is 14. Okay, so once you find the inner radius plus the width of the track will give you the outer radius. The inner radius plus the width of the track will give you the outer radius. Now the question is to find the area of the track. You need to find the area of the track. So what is the track made up of? The track is made up of two rectangles. Can you see here? This one rectangle. The track is made up of this rectangle, and these semicircular ends. See this one, this piece, and this piece. When you put this together, it will make this one, right? When you put these two ends together, it look like this. So you'll have to find the area of this portion. And how do you find the area of this portion? Pi capital R square minus small r square. Pi capital R square minus small r square. When you put this piece, the ends together, this is called a circular ring. And how do you find the area of a circular ring? Pi r square minus r square. So the area of the track is area of these two rectangles. Area of this rectangle plus the area of this rectangle plus the area of this ring. Plus the area of this ring. So how do you find the area of a rectangle? L into B. 60 into 7. 60 is the length and 7 is the breadth of the rectangle. Similarly here also 60 into 7, length into breadth. And now for this one, both the radius. We worked this and we found small r. And small r plus 7 is equal to capital R. So put that in this formula and find the area of this, the two ends together. Now the area of the track is this area plus the area of this ring will be the area of the track. Also find the outer perimeter of the track. So to find the outer perimeter, it will be 60 plus pi r plus 60 plus pi r. So 60, 120 plus pi r, and pi r is 2 pi r. So that is 2 into 22 by 7 into r. So I just assumed inner radius to be 14. So 14 plus 7, 21. So substitute that and you'll get the outer perimeter. Yeah, please work. All right. I hope all of you have completed. So I hope this, running track details are clear about the straight portions, 4 straight portions. Here 60 meters each, 4 semicircles, two semicircles with radius r, and 2 semicircles with radius capital R. So inside perimeter is 60 plus pi small r plus 60 plus pi small r. Because this is the length of the semicircle, right? Length of the semicircle is pi r. Length of the semicircle pi r. So this is the inside perimeter, which is 340. When you work this, you're able to find the value of r. R is 35. And so capital R will be small r plus the thickness of the track, the width of the track. 35 plus 7, 42. Next, so we have to find the area of the track. Area of the track is area of the two rectangles, L into B into 2. L into B into 2, area of two rectangles. L is 60, breadth is 7 into 2, because two rectangles. And here this one is, see, the area of a portion like this, is pi r square minus r square in by 2. Because this is half of the full ring, right? This one is half of the full ring. This one is half of the full ring. This is the full ring. This is the full ring whose area is pi r square minus r square. This is half of the full ring. So I've written half pi r square minus r square. Like that you have another one, right? So into 2. This is half pi r square minus r square. And this is the other half. So 2 into half pi r square minus r square. Or you can write this directly. That is the areas of the two rings together. The areas of the two rings together, the two pieces together, is pi r square minus r square, like this. I've just written for this and multiplied by 2. You can just put both of this together and say the area is pi r square minus r square. So substitute r is 42, capital R is 42, small r is 35, and this is the area of the track. Outer perimeter 60 plus 60 plus pi capital R plus pi capital R. Finished, all of you? Oh, it's time. Okay, we'll just do this one and wind up the session for today. Find the number of rounds that a wheel of diameter 7 by 11 meters will make in going 4 kilometers. Find the number of rounds, that is the number of revolutions, that a wheel of diameter 7 by 11 meters. So radius is 7 by 11 divided by 2. So 7 by 11 into 1 by 2. So 7 by 22 is the radius. 7 by 11 divided by 2. So 7 by 11 into 1 by 2. 7 by 22 is the radius. Okay, radius is 7 by 22. The distance is 4 kilometers. 7 by 22 meters, okay? Distance is 4 kilometers. We need to find the number of rounds. Okay. So let's just write a formula. The distance covered by the wheel, distance covered by the wheel in one round into number of rounds is equal to the total distance covered. That's all. Is equal to the total distance covered. See, this is simple, no? Distance covered by the wheel in one round. The distance covered by the wheel in one round into the number of rounds the wheel goes will be equal to the total distance covered. So what is the distance covered by the wheel in one round? 2 pi r. Circumference, no? The distance covered by the wheel in one round will be equal to the circumference of the wheel, 2 pi r, into number of rounds. We don't know. That's what we have to find. Number of rounds is equal to the total distance covered, 4 kilometers. But since the diameter is given in meters, you'll have to convert kilometers to meters, 4,000 meters. Because diameter is in meter, right? So your radius also will be in meter. And in one equation, all the values must have the same unit. So if radius is in meter, the total distance covered also should be in meter. Okay, so 2 pi r into number of rounds is equal to 4,000 meters. So now 2 into 22 by 7 into r. We just work, no? 7 by 22. 7 by 11 is the diameter divided by 2. So 7 by 11 into 1 by 2. Okay, so 2 into 22 by 7 into r, 7 by 22 into the number of rounds. Okay, into number of rounds is equal to 4,000. So number of rounds will be 4,000. Take all these numbers to the other side. So it will become into 1 by 2 into 7 by, okay, you can cancel this here. No? So number of rounds is equal to 4,000 by 2, 2,000. Understood, children?
Yes, ma'am.
Okay. Oh. Sorry, by mistake, I unshared my screen. 1 minute. Yeah. Yeah, children. Take down this working, no? Don't do both now. It's time. Both are fine. Just ignore this working. Just ignore this. Take down this working, children. Write the question and take down this working. I think we discussed this one. This is that is okay. That is. That is. Okay. Completed, children? Well, it's time. If you have not done, please take a screenshot. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Yeah.